106B. Hopefully you're in the right room. I know there's a lot of people here, not a lot of extra chairs, but don't worry, that will change very quickly as the quarter goes on. I know how you young people are about coming to class. There are a few chairs up there. Shout out to the one dude who found the upstairs balcony. There's about 20 chairs up there. I do not know how you get up there, but he figured it out. He might have climbed up there. I don't know. Everybody leaves. Bye. Suckers. Yeah, so this is Computer Science 106B. My name is Marty Stepp. I'm the instructor. Today we're going to kind of go through some of the class policies, all that usual boring bullshit that you do on the first day of school. I will try to go as fast as I can through that, and then the last half of class I'll try to teach a little bit of programming stuff, okay? That's the plan. I don't have any paper handouts for you guys. I only print exams, that's it. So I don't even print my first day syllabus or any of that. If you want documents, here's where to get them. The course website is cs106b.stanford.edu. And if you forget that or lose it, if you Google it, it's the first hit, so it's pretty hard to miss. All the stuff we're going to do every day is going to be there. The lecture slides that I use, any programs I write, any handouts, any homework assignments, all kinds of stuff is there. And I post stuff right after class. I'm also currently recording this presentation, this lecture, as a video. So it's always the number one question is, are the lectures on video? The answer is sort of. They're not on any good video. I'm running a program that's capturing my screen and recording the computer's built-in microphone. And it sort of kind of captures the lecture. And I will post those after every lecture. But you won't see me, my smiling face. You'll only see my screen like this. And the audio, if I stand over there, it's kind of hard to hear me. So the audio is a little bit iffy. So there are crappy videos, but they're not good videos. But, if you have to miss a lecture here and there, you can watch those to try to catch up. So that's the answer to that. Also, I cannot promise you that every single lecture will have a video, because occasionally my computer crashes and then I lose the file that's trying to record. So I will try my best to record these videos for you guys. Anyway, that's the most important thing I think for today is this URL. Figure out how to get to the class website. If you want to follow along with me right now, you can go there with your browser. So I'm going to open up my first deck of slides for today. So I'm going to go through a bunch of information that is in detail on our course information handout. So the course information handout, if you go to our website and if you click the handouts link, you get to this page with all these documents that might be useful. I think you should read through a couple of these after class today. So here's kind of some general things about me and about this class. As again, my name is Marty Stepp, and my email is stepp@cs.stanford.edu. I have two wonderful teaching assistants who are going to help run the show. They're Amy and Ashley. They're sitting up here. Can you guys stand up and wave to everybody? Amy in red, Ashley in teal. And they're going to do a ton of work to help keep things going. And they have no idea what they're in for. Because I'm extraordinarily lazy and domineering as a boss. A little bit about me. I've been working here at Stanford since 2013. Before that, I was a teacher at University of Washington up in Seattle. Anybody here from Washington State? Kind of reminds you of that out there today, doesn't it? Huh? You thought you got away from that crap moving here. Nope. Every so often you get a Seattle day in the Bay Area. So yeah, what else about me? I have a lot of animals. I have 3 dogs and 2 cats. If you come to class, I know you guys hate coming to class. If you come to class, I will show you pictures of my dogs. That's all I have to offer. Here's a picture of my dogs. The brown one is Barney. The black one is Clyde. We got them together, Barney and Clyde. We thought that was funny. And the little white French bulldog is Abby. If you guys are really good, one day I'll show you the video I recorded of them all meeting for the first time. It might melt you. It's really cute. So yeah, that's all I have to give is puppy pictures and or puppy videos. The other news with me is that I'm happy to announce my wife and I are expecting our first child at the end of February. And so that'll make the end of the quarter really interesting for me. Very busy. That's what I said about these 2 TAs doing a lot of work. They're going to kind of help keep things running when I run off to be a dad and stuff. So yeah, that's me. So, okay, a little bit about the course. In addition to the two TAs, how many of you took 106A here at Stanford, right? Most of you, right? With Meron? I got bad news for you guys. I'm way worse than Meron. Meron is fun, and he's nice, and he says cool things like, that's life in the city, or whatever he says. He throws food at you. I don't do anything except swear a lot and have dogs. That's kind of all I have going for me. Sorry. But anyway, the section leaders will make up for that, though, because they'll help you. You know about our section leaders if you took 106A. These are undergrads who took the class recently, and they will run these weekly discussion sections. It's just like 106A. You'll meet with them once a week for 50 minutes in a smaller group of 10 to 12 students. You'll work on practice problems, and you'll be given points for participating in those sections. You don't have to come to these lectures, although I wish you would come. You are given points for going to the sections, so you should attend those. The sections begin next week. There's no section this week. There will be an online link that goes up, I believe, on Thursday, where you will tell us what times that you're free, and then we will assign you to a discussion section. So you'll get a message from me at the end of the week reminding you to do that. So yeah, section leaders do a lot to keep this course running. They're the strength of our 106 program. I'm excited to work with them. Okay, so that's the section leaders. Stop me at any point if you have any questions along the way. One question a lot of people ask at the start of 106 is, am I in the right course? Is this the right course for me? Well, that depends on you, but all I can do is kind of tell you what these courses are, and I think it's kind of up to you to figure out which one is best for you. If you already took 106A, then yes, you're probably in the right place. 106A is our introduction. If you haven't programmed before, you should probably be in 106A. 106B follows that. I assume that you know basic things like about variables and data types, if statements, loops, methods, parameters, return, arrays or data structures, objects, classes. If you don't know most of those words that I just said, maybe you should be in 106A. Anyway, we're going to build on all of that. We're going to switch programming languages. 106A was taught in Java. We're going to use a language called C++. We can talk about why we're doing that later. But anyway, we're going to talk more about data and about algorithms, how to process large sets of data. I think this is the class that really enables you to solve really complicated, interesting problems. Also, a lot of the stuff we do ends up being fodder for job interview questions later for internships, so hopefully it'll help you guys out. 106X is our other offering. It's basically a harder version of 106B. It's typically for people who have already programmed a lot before college, or people who just are really bored by the pace of 106A and B, and they want a really intense experience with more problems and more challenge, and also kind of want to be around a group of like-minded students who want that challenge together. So, B is the class for most people, for the general Stanford population, and X is for this subset that has a lot of prior experience. So if you want to know which class is right for you and you still don't feel like you have enough information to answer that, my suggestion would be go to the class website. I don't know if my internet is working in here, but if you click on FAQ, frequently asked questions, oops, no, it's not working. If you were to click that link in a room that had working internet, you would see the very first question in the frequently asked question page is, which class is right for me? And it has more links and info, and you can click through to go to the previous quarter's website to look at some of the problems that they solve, and it might help you see, like, if these problems look hard or easy for me, that might help me know how to place myself. After looking at all that, if you still have questions, you can email me and the TAs to ask about it. But in general, like if all 400 of you or whatever email us, that's a lot. So I would encourage you to look at this stuff before emailing us your questions about that. So yeah, that's kind of my quick spiel on the classes. This quarter, the 106X class, I believe, has this special R distinction where they're going to do a focus on research and work that's being done in our field and our department. That sounds pretty cool. So yeah, do you guys have any questions about these courses in general that I didn't cover so far? Anybody here who's never programmed before? Nobody brave enough to raise their hand? Okay. Anybody here take 106A from me? Hey, look how few people came back for more. Do you see that? There's like 3 people, and they were all weeping as, oh, yes, this is the only quarter I could take B. Well, good to see you again. There's also a class called 106L. It's a sort of 1-unit lab class that's on the side of 106B, where you go in more depth on the C++ language. I mentioned that we're using C++ as the language that we're going to program in this course, But we're not going to try to learn the depth of that whole language. We're just going to learn as much of it as we need to solve the problems we want to solve. 106L really is focused on that language. Like if you want to be able to say, I know a lot about C++, you would want to take 106L. So if you're interested in that class, you may want to go to their webpage, cs106l.stanford.edu, to learn more about it, or you can contact the instructor named Ali, who will answer your questions. I may have Ali come in on Wednesday to speak about the 106L briefly as well. So check that out if you think C++ sounds cool. Okay, so a couple more things about the class. We have a textbook. It's called Programming Abstractions in C++. It's written by Professor Eric Roberts, who's a retired emeritus professor in our department. It's written for this course by people at Stanford. So this isn't going to be one of those books that has nothing to do with the class material that you sometimes have to buy. Now, having said that, I'm not going to ever assign you any required homework problems that come straight out of the book. So technically, it's possible to complete the class and get an A+ or whatever grade you want to get without buying the book. I still think you might want to buy it because you are allowed to use the book on the exam. It's an open book exam. It's closed notes. So all you can bring is the book. So that might help you as a reference on the exam. I do bring a few loaner copies during the exam, but there are many of you, and there are a few loaner copies. So it's harder to get the reference you need without a copy of the book. My suggestion is either buy one or find a way to have access to one when you need it. There is a PDF version of the book on the class website for free, but I'm not going to let you bring any computing devices to the midterm and final, so you can't use that as your exam reference. You could use it during the rest of the course. Okay? So my goal is I want to convince you it's useful, but I also don't want you to feel forced to purchase it if you don't think you can afford it or you don't think it will help you. Question? Can you print a PDF? Is that what you said? No, I don't allow any loose papers during the test. So actually that won't be allowed during the exam. And I know that probably sounds really strict that I don't allow that, but the reason I do that is because I like to give you a whole bunch of practice problems ahead of the test. And then on the real test, I like to give you problems that are really, really similar to those practice problems. So if you practice and study a lot, you should be totally prepared to nail it on the real test. But if I let you bring all those practice tests in, it makes the real test too easy then. So I have to basically not let you bring in these notes and papers and stuff in order to have that kind of an exam. So that's why I have that policy. But yeah, so if you want the book in the test, you have to basically buy the physical tree version of the book. Another question, yeah?
We can have notes in the book, right? Like our own notes.
You can make little notes or highlighting or whatever. I've seen people who try to write microfiche, tiny little notes that they use a magnifying glass, and they write down all the handouts in the margin or whatever. So I think you can have sort of normal notes, but not. Don't try to rewrite all of your study materials in tiny font in the margins or whatever. Yeah, but you are allowed to annotate your copy. Yeah. Any other book questions? Yeah.
I heard that you give reference sheets with methods on them.
I do give kind of a basic reference sheet on the back of the test, which has some of the common methods that you might want to call and stuff. So, I mean, if you can't remember the name of some function that you need, usually you can get that on that reference sheet. But the book might be more useful for like a concept that was a little fuzzy or something. Yeah. Okay, so that's the book. Homework, this is a lot like 106A. We have 7 assignments this quarter. Each one is out for around a week or a week and a lecture-ish. We are going to have pair programming. If you want, you can work with an optional partner after assignment 1. Assignment 1 is individual, and the rest are going to be pairs allowed. The assignments are graded similar to A, where you have a functionality score, does your program behave correctly, and you have a style score, which is has your code been written elegantly in a clean way. And so if you took 106A here, that should be pretty familiar. We also have this bucket grading system, just like 106A, where a really good program would get a mark called check plus. A fairly good program that needs a little bit of improvement would get a mark called check. And a program that needs a lot of work, it gets a mark called check minus. We have a few other marks that are rarely given for extreme cases. Most students get checks or check pluses statistically. And you get your grades back by meeting in person with your section leader every week. You schedule times and you go meet with them in person and you go over your program, what you did well, what you can do better. So all that's the same as 106A. And we have this late day policy, which I believe is also the same as 106A, where up to, I believe you get, do we have 3? Let me check how many I gave you. I forget how many late days you get. Late is 4. You get 4 late days. So throughout the quarter, I know, see, I love you guys. I bring you puppies and late days and bad words. Come on, what's not to like? Up to 4 times during the quarter, you can turn in something late without a penalty. The unit of lateness in this class is a lecture. So like if it would have been due on Wednesday and you turn it in by the same time on Friday, that counts as like 1 unit late, 1 day late. And usually the penalty for turning things in late is you go down one of those buckets. You go from check plus to check, you go from check to check minus, etc. But if you have these late days left, they buffer you against those penalties. So the first 4 such penalties get waived. So you can either turn in 4 things 1 lecture later, 2 things 2 lectures late, etc. The most you can turn something in late is 2 lecture days in this class. So after 2 lecture days worth of lateness, we don't accept anything regardless of how many of these late days that you have remaining. So that's our policy. It should be pretty much the same general system as 106A. Do you guys have any questions about that, about the homework grading or about the lateness policy? I will say this mostly counts as my leniency policy. Like if you email me and you say, I've got a really sore throat, it's hard to work on the homework assignment, can I please have an extension? I will say, I already gave you 4 extensions. Use one of them. In other words, unless you're seriously incapacitated, this is what I want you to use when you're sick, when your boyfriend or girlfriend or non-binary friend visits, or when it's your family member's bar mitzvah and you want to go away for the weekend. Whatever whatever it is, use these to handle those. And only in extreme cases would I give other extensions or relaxations of due dates in addition to these. Okay. So grades are determined by this weighting. Your homework and your section participation count as half of your grade, and your exams count as the other half. And at the end of the quarter, we map the grades to A's and B's and C's and so on. That's a little confusing because we have those checks and check pluses, and students always want to know, like, what do those mean? Is a check plus an A? Is a check a B? Kind of. It depends how many people get check pluses and how many people get checks. I map them smoothly to a curve at the end of the quarter. I try to make sure that everybody gets at least the following mapping. If you earn 90% of the possible points, I'll make sure you get at least an A minus in the course, and 80% I'll make sure you get at least a B minus, and so on. In practice, what we really do is we make sure that almost exactly half of the students in the course get an A minus or better. So 50% roughly of you guys will get A range. And then 30% of you will get in the B range, and then the other 20% are spread throughout the other marks. So, the grades, I think a lot of students are concerned about grades. Of course you are. You guys are high achievers. In general, I would say the grading curve is fairly lenient, in my opinion, anyway. I'm old, so I remember when it was a little harder than that. But, hey, whatever. This is the grading curve that we usually fit things to. Any questions about the grading? I would say, in general, most students, at a given point in the quarter, most students are doing better than they think they're doing. I have people come into me and they say, should I drop the course? I don't know, I got a check minus on one of the assignments or whatever. And it's like, no, they're probably getting like a B plus or an A minus, and they're thinking about dropping the course. It's just, sometimes I think students think they're doing worse than they are. Your grade's probably going to be fine if you show up and turn things in and do your best. You'll probably do fine on your grade. The software that we're going to use to write our homework assignments is called Qt Creator. It's one of many possible editors that a person could choose to use to write C++ programs. It's the only one I will help you use. It's the only one the TAs and section leaders will help you to use. If you like some other editor, that's great, but I'm not willing to help you with that other editor. I don't care about Xcode or Eclipse or Visual Studio or whatever. I don't help you with those things. So if you want to work on our homework assignments, I strongly recommend that you install this editor. The way that you can install this on your computer is there's a link on the class web page that says Qt Creator. I'm not able to click on it. But if I could click on it, it would have instructions. Please, if you're going to install this, please follow our instructions. Don't just Google for Qt Creator and click on that link. You should click on our link because we have some extra steps we want you to do. That would be a great thing you could go do between now and Wednesday, would be install Qt Creator. Then you'll be ready to rock for the homework. It's a shame when students want to start homework 1, but they can't because their laptop isn't working. Most of the questions we get in the first week and a half are about how Qt Creator didn't install properly. So I would suggest getting on that as soon as you can. If you don't have a laptop or don't have access to one, this software Qt Creator is installed in the cluster machine, so you can use it there too. Everybody's got to install this, even if you end up working in pairs. I want everybody to set it up. So that's that. If you want help, this is a challenging class, not as hard as X, but it's still challenging. If you need help, we'd love to help you. I mean, that's our model, right? We'll give you a hard class, but we'll give you a lot of help. And the main vehicle for help is the section leaders, and they're located in our lab. It's called the Lair. It's in the first floor of Treseder. We take it over in the evening, Sunday through Thursday. Starts next week. They're not open yet. They'll be there. Section leaders will be there. They'll help you with homework. They'll help you with Q Creator. They'll help you with whatever you want. Great resource. Gets a little busy the night before the assignment is due, so sometimes you want to go a little early, but that's up to you. There's other resources. We have a message forum, a Piazza forum you can post on linked on the class website. You can come to my office hours or the two TA's office hours. You can email people. You can look at the other. We provide a lot of code and materials like the book and lecture slides and handouts and all that stuff. So there's a lot of things you can do to get help if you need it. And I'm saying all this as a preface for talking about ways that you shouldn't ask for help, which would be kind of related to this honor code. The honor code basically means I trust you guys will be good and not plagiarize and not cheat on things, and you trust that I'll treat you like adults in return. Wait, did I say that wrong? I think I just said two of the same way. I trust you guys to be good, and you trust me to treat you like grown-ups, whatever. So I still don't know if I said that right, but don't cheat. That's the point of the honor code. As it applies to this class, that means don't copy other people's work. Don't give your solutions to other people. Don't Google and try to find solutions. Don't go on Baidu. Don't go on Pirate Bay. Don't go on Pornhub, wherever it is that you find your solutions. I doubt they have our assignments there anyway. Don't ask the Russians for help. Nobody. Listen. You like that? I got Michael Flynn in the crowd here today. Look, don't turn in work that isn't your work. That's all it is. If you need help, we'll help you. But if you're stuck, ask us for help. Don't Google and copy somebody's code on the internet. Okay? That's the idea. I run software that checks every program that's been submitted since you were born that was ever turned in here, and every program we're able to find on the internet. We're pretty good at looking for programs on the internet, so if you copy from somewhere, we'll probably detect it in this software. So please don't do that. I don't want you to do that. Some people worry about false positives, like what if I happen to write something that's kind of similar to somebody else's? Is this thing going to flag me falsely and accuse me of cheating? I would say don't worry about that. The software is not the decider. We decide. We look at the software's suggestions and we choose a subset of them. And we don't choose things that look like they're a little similar or there's a happenstance similarity. We only choose things that are blatantly copied. Sometimes the similarities are hilariously bad, like you put her name on the top of your file when you turn it in. Oops, you forgot to change the name. Or it's like literally character for character, the exact same code on Google, first hit for the homework assignment or whatever. So usually we don't accuse these unless it's blatant. This policy will probably not affect 99% of you, but there's somebody in the room who's going to be, I don't think it's an evil person, it's just like somebody who's going to get stuck and they're going to say, I don't know what to do, I can't take a 0 on this, and they're going to Google it and copy it and turn it in. And then I'm going to give them a call, and that won't be a good outcome. So if you're stuck, please ask for help in other ways. Also, keep in mind, you can work in pairs on most of these assignments. So if you're stuck, why don't you get a partner? I'll help you find a partner. You can work with somebody, and the two of you can probably figure it out. Okay? Do you have any questions about this honor code stuff, how it applies to you, how we're going to enforce it, what we expect of you in this course? Yes? Does your partner have to be in the same section with you? I think yes, right? Isn't that what we asked for? Yeah. And if you say, well, but they aren't, well, then we can move you so that you are in the same section. We can usually, if you want to work with that person, we can usually make that work out. There are a few constraints. I encourage you to read the course info handout. One constraint is if one of you is taking it pass-fail and the other one isn't, we don't want you to work together. And you have to be in the same section. But other than that, yeah, you can choose your own partner. When you sign up for your section, when you submit your preferences, you can tell us, I really want to be in the same section as Joe because we want to work together. And we will try very hard to accommodate that. Okay? I think that's all my policy stuff. I'm not done with lecture, but that's my policy stuff. Do you guys have any other questions about what the class is or any of these policies, any of the stuff I've said so far? Any questions about my dogs? No. I've got 2 cats too, you know. But we won't discuss them. You know, my wife, when she got pregnant, she found this article that said, like, you should avoid contaminated sources like litter boxes. So I got to clean the damn litter box for 9 straight months now. Come on, what's up with that? If anybody can find me a page that says it's okay to clean a litter box when you're pregnant, I'll give you a lot of extra credit if you email me that link. I need it. Is that? Are you have questions? Go ahead.
Can you clarify what you mean by that if you guys have made a mistake?
Yeah, that last bullet, I don't think or the second to last for the last bullet, if you've made a mistake, yeah, occasionally a person does copy something, copy another student or copy something on the web, and they turn it in. And then the next day or that night they're laying there and they go, oh man, I screwed up. I shouldn't have done that. I don't want credit that I don't deserve, and I don't want to get busted. And you can email your section leader and say, hey, my homework 4 submission, I want to retract it. I don't want you to grade it, I want you to just throw it out. And with no questions asked, we do that. And we don't assume anything. There's lots of reasons why you might want to do that. It's no big deal. And so, yeah, if you realize you made a mistake and you want to do the right thing, we'll give you an opportunity to do that. Yeah. Question?
So does that assignment count as a 0, or is it just like not included in your grade base?
If you retract an assignment, you didn't submit it. So you do get a 0, which isn't great, but it's better than getting busted for this kind of stuff, right? So, yeah. It's not without consequence, but it's better than the alternative. Yeah?
So if you retract something, you use late days where you submit there.
If you retract and you still have late days, you theoretically could start over and write a valid solution and turn it in. That would be fine. Yeah, but just be careful not to don't re-Google the bad stuff you Googled before, right? Sure, of course. I don't want you guys to feel forced into doing the wrong thing. I want to give you help. I want to give you flexibility to do the right thing. Okay? Can I teach you guys some C++? That just wasn't a lot of energy. I don't know. Do you guys want to learn some C++? Yeah! I heard a lot of, I guess. I don't know. What are you watching? Is that Black Mirror? Let's watch that. Okay. Season 4 is pretty good. Okay, let's do a little bit of C++. We got about 20 minutes left. This comes from, I'll often mention reading, like on the lecture calendar. We have a calendar of what we do every day. Where is that? So, I'll mention what we're doing, any reading that's related. I will mention, I'll have slide links. I'll have a link to, if I'm writing any code, I'll have a zip you can download. That's all here for today already. I also have this site called Code Step by Step. Ha ha ha, I named it after myself. Where you can do practice problems on there and get answers. I'll talk about that tool later. I don't have a lot of time for that today. But anyway, here's the start, chapters 1 and 2 of the book, Introduction to C++. C++ has been around since 1983. It was made by that guy, Bjarne Stroustrup, and it was built as a systems programming language, which means it's close to the hardware. It's good for writing operating systems and device drivers and things that are close to the computer hardware, games, things that need lots of graphical performance, stuff like that. It's used for all kinds of things today. It's one of the world's most popular languages. I didn't look it up this week, but it's somewhere in the top 5 or 6 programming languages in the world, despite being, almost as old as me. It's pretty similar in some ways to Java. So if you took 106A here and you learned Java, a lot of that stuff should be fairly familiar. Some of you might have come from the JavaScript version of 106A with Jerry Kane. Anybody come from that class? Well, look, C++ is more different from JavaScript than it is from Java. Sometimes I'll say, this is like the so-and-so in Java, and you'll say, I don't know what that is, but whatever, just ignore that part. Maybe I'll throw you occasional bone and I'll say what it's like in JavaScript. You guys should be okay. If you know basics of programming, JavaScript, Java, it shouldn't be too bad for you to transition to this language. A lot of the stuff I'll show you should look fairly vaguely familiar. So here's a C++ program. So at the start, I've got a comment in green. That syntax is the same as Java and JavaScript. You know what comments are, right? I have 2 lines at the top that say include and using. Those are like what are called import statements in Java. It's basically you want to link to a library, some other source of code that you want to interact with. I'll talk about these pieces in more detail in a minute. The int main, if you took the 106A in Java, you've written main before. That's a piece of code, a function that runs to execute your program. I don't know what they did. Did they do a main function in 106A in the JavaScript version? Do they have a main, or do they call it run? Or what's the thing you write to get the program going? Run? Okay, well, yes, fine. It's basically the same as the run or the main. There's a special function that's your program. That's where the program starts running. It's called main in C++. And yeah, this is a program that just prints out a message that says hello world on a console. And I'm going to talk about all these different pieces in just a second, but that's our first program, okay? And you'd save it in a file with an extension of .cpp. That's the file used for C++ programs. So when you write C++ code in a CPP file, occasionally you have multiple files. Sometimes you have these extra files called header files .h that we talk about later. you compile your program, and you get these output files that are called O files, object files. In Java, when you compile your program, what do you get? What kind of file do you get? It goes from a .java into a .jar. You get a .class, which you can later make into a .jar. So close. In C++, you get this .o file, and then you can turn a .o file into an executable file, which on Windows has extension .exe. On other operating systems, has no extension at all. One thing that's interesting about compiling C++ programs is that the binary version, the compiled version that you get, only runs on that operating system. In Java, when you compile your program, that compiled version you could send to a Mac or a Linux or a toaster or whatever, and it'll run on anything. It's the same version of the compiled code. In C++, if you want it to run on those other platforms, you have to take the source code and put it on each of those platforms and recompile it to get it to work. You might say that's bad, I don't like that, but one of the side effects of that is that each version can be very optimized for that platform. So it's a good thing and a bad thing. If you're using JavaScript, you don't always really compile your program at all. You just write it and then you run it. So this is a step that you may not have done as much if you did JavaScript. But you have to explicitly translate your source code into a binary form that can be executed. And this compilation process would be where you might see errors if you had illegal syntax, something like that. Okay? So here's this main function that I talked about. You write int main. So in JavaScript, you would say function main. In Java, you would say public void main or public static void main or something like that. What's the word int before the word main? What does that represent? What's int mean? Yes?
It's the type of variable you're going to return.
Yeah, it's a variable type representing integers. And in this context, we're writing that data type because we're going to return a value that is an int. Yeah, returning a value out of main may not make very much sense. You guys probably wrote functions or methods that return things, right? Like, why do you return things from a function? What does that accomplish? Yes?
We want to know what happened with the program.
So like you have two functions, and the first one calls the second one, and the second one calculates something. And they want to send that calculation back to the first one, and the first one wants to know what that calculation result was. You return it to send that information back to the... Yeah, so it's when two functions are talking to each other, A calls B, and B wants to send something back to A, a message, a result, something back to A. That's when you return stuff. So in that description, which would apply to Java or JavaScript, it might not make sense to like return something from main, because returning from main means like exiting the program. These ints that are being returned are actually exit codes that are sent to the operating system. We aren't going to worry about them. You don't need them for our course. We're always going to just write return 0 at the end of main. It's just this line that we always have to write for the program to compile. So don't worry about the int and the return 0. We're always going to say that in every single program we write this quarter. Okay? So here's just a bunch of random syntax from C++. The point of this slide is that it's very similar to Java. And if you're from JavaScript, it's fairly similar, except in Java and C++, when you declare variables, you have to write what their data types are. So in JavaScript, you'd say var or let. Like you don't say what type something is. It has a type. It's an int or it's a string or whatever, but you don't say what type it is. In languages like Java and C++, you do have to say the type of a variable when you declare it. So if you say int x equals whatever, it'll calculate that result and store it in x. X is an integer variable. Double is a real number. That's another distinction from JavaScript. JavaScript, all numbers are just the number type. In Java and C++, there's int for integers and double for real numbers with decimal points. You have Boolean values. You guys remember what Booleans are for? True and false. Why would you want that? It seems like a type that doesn't have a lot of different values in it. What would you use them for? Why would you want a Boolean? Any idea? Somebody I haven't called on, yeah. A condition or logic. You want to return a value. Is this a prime number or is this a leap year or whatever? True or false. Yeah, you want to use logic. You want to have functions or methods that calculate logic things. So Boolean is a logical type for remembering whether something's true or false. I got for loops here. I got while loops here. Those are the same as Java and JavaScript. This is the syntax for calling a function. That should look similar. You write the name of the function. You put parentheses. If the function has any parameters, you put the parameters inside the parentheses, separated by commas. Every statement ends with a semicolon. So I think most of this stuff should be pretty familiar to you guys. So that's the good news. C++ is, the general syntax is fairly similar. And look, it's not a coincidence that it's fairly similar. Java mostly ripped off C++. It came after, about 10 years after, and they said, you know what's a good language? C++. Let's copy that. Ha ha ha, famous last words. So yeah, that's why that they're pretty similar here, right? Come from a similar family of languages. Okay, let's go back to some of those statements in the program that I skipped over. There's this include statement. This is very much the same as an import statement in Java. I don't know what they called it in 106AJ. Did they have an import statement or a require statement, or you could load a library or something? Did they give you any statement like that? Or did you just put the library in the same folder and it just worked or something? Did you guys have libraries? No? I don't know. I already lost all the JavaScript people. They're already mad at me. I don't know. So look, if there's a provided piece of code that your program wants to interact with, you include that code in your file. It links to that library in your program. There's two syntaxes for the include statement. One is that you write the name of the library in brackets, less than, greater than brackets. If you do that, that means you're linking to a system library that's included with the C++ compiler. If you do the other syntax, you put quotation marks around the name of the library and you write a .h extension at the end of the name of the library. If you do that, that means you're using a local library which is included in your little project that you're working on. So the difference is, in this course, we have a bunch of libraries that we're going to use that are written here at Stanford. Stanford C++ libraries. We use them because it helps make this class a little easier, helps smooth out some of the rough edges, helps us do some cool things like graphics or animation or whatever. And when you link to our Stanford libraries, you'll use that second syntax. But when you link to things that are in the core of the language that come with C++, you'll use that first syntax. I think it's confusing, and the good news is most of the time, I'll just tell you exactly what you need to include to solve a certain problem, and you don't have to worry about it too much. This is kind of just a dumb C++ thing. One thing you'll discover as we go through this course is I don't like C++ very much. And I will not be shy about telling you things I don't like about C++. This syntax having two different forms is one of those things, but whatever. Anyway, that's how you include a library. To make things a little more confusing, there's also this statement called using. If you write a using statement, it basically makes it so that names from a library are accessible in your program. I think it's confusing because most languages don't separate these concepts. Most of the time when you include a library in your program, now you can use all the things from that library. But in C++, sometimes you also have to add this using statement to access the symbols that came from a library. You access the names that came from that library. I mean, the short version here is that we are going to have, in all of our programs, we're going to have this statement at the top that says using namespace standard. And basically what this means is all of the variables and functions and things that came out of this library or whatever library, I want to be able to refer to those names in my program. So whatever, this is kind of just mumbo jumbo that's going to go at the top of our program so we can access different things. I don't think I did a great job of explaining it, but whatever. So if you don't use a using statement, there is an alternative syntax that you can use, but I don't want to use that alternative syntax, so I'm going to skip it. Now, I want to talk about input and output, like interacting with a console. That's kind of the first type of program that we usually do. We're not doing Carol the Robot in C++ here today. We're just printing messages like println, that kind of stuff, you know. So if you want to output stuff to the console in C++, you write cout. It's the C output object. And you use this less than, I've heard it called the waka waka operator, or the alligators operator, I don't know, whatever. You write less than to print a message to the console. If you want to concatenate and glue together pieces of the message, like in this example, I've taken a variable that isn't declared on the slide called age, and I want to insert that variable's value into the output. You exit out of your little quoted string, and then you write another less than, and you write the variable, and then you continue from there. In languages like Java and JavaScript, how do you glue together pieces of output? Use the plus sign, right? In this language, you use less than when you're printing things like that. Now, there's also, if you print these things with this cout command, by default it does not drop down to the next line. If you use the println command in Java, it does drop to the next line after each call. But here it doesn't. If you want to go to the next line, you have to put this thing at the end of your line that says end line. You can also write /n in quotes, but endl is better because it's more compatible with different operating systems and stuff. So you should write endl. So like over here, I've got this editor. This is the Qt Creator software. I'm not going to spend a lot of time today teaching you all about this software. I will in the right time, but I don't have a lot of minutes here. So in this software, if you want to write a message like hello world, there's an example, see out hello world endl. That means print hello world and then go to the end of the line, go to the next line. So if I want to insert like a variable here, I could do something like, int age equals 29. And I could say like see out Marty wishes he were age, exclamation mark, endl. So it's like I've inserted the value of that variable into the output. I compile, I use a lot of hotkeys. If you want to learn these hotkeys, you could go in here, like build it, compiling is Control B, running is Control R. So if you see magic stuff happen, it's because I'm using Ninja hotkeys and stuff. So if I hit Control R, it runs the program and it says, hello world, Marty wishes he were 29. So I inserted the value of that variable, right? Okay, so that's just basic input and output stuff. There's also a cin. Cin would be like you want to ask the user for input. You want them to type something that impacts the program. I think in Java we call it read line or something like that. I don't know what they did in JavaScript. Maybe they had the same library in JavaScript. But you can ask the user to type in their age, and then it'll print that in the program. So I'll show you that right now. It uses the sort of opposite direction alligator operator. Instead of age equals 29, you can just say, see out how old are you? Question mark. And then I could say cin age. Notice it's the other way. It's kind of like cin is sending a value into that variable. Then I could say, yeah, right, Marty wishes he were age. So if I run this program, it says, hello world, how old are you? And I can say, 35. Yeah, right, Marty wishes he were 35. I'm 38. But anyway, I'm going to cut that part out of the video, I guess. I won't tell anybody. But that seems fine. Cin, you can read the variable. But, of course, what happens is if you do something bad, like you type, how old are you? None of your business. It says, yeah, right, Marty wishes he were 0. So it doesn't really do the right thing of what I would want it to do. Also, it doesn't do anything like checking for negative numbers or whatever, right? Like, and what if I type, how old are you? Well, 38.2463. I'm going to be real precise. It kind of works for that, but anyway, these cin commands are discouraged. We don't think you should use them, particularly because of that case where I typed in letters and it just made a 0. It just did the wrong thing. So we suggest a different way of reading user input, which is to use one of our Stanford libraries. So if you include this heading in your program called simpleio, simpio.h, then now you'll have access to these functions here. Get integer, get real. I like that one. Get real, man. Get line, get yes or no. You can ask the user these questions, and it will return the answer. And what's cool about them is if they type something invalid, it will re-prompt them. So, for example, if I go back here and I say, how old are you, cin age, instead of these 2 lines, what I do is I say int age equals get integer, how old are you? So it's like you pass in the string to prompt them with, to print. You know what I mean? And then I don't have to do cin anymore because it sort of implicitly does that. I also don't need to declare the variable up above because I'm reading it down below. So I kind of eliminated some of those lines there. If I compile this, it says, I don't know if you can read that, but it says get integer was not declared. What's the problem? Do you know? I need to include, yeah, like so on the slide there it says include simpio.h. Okay, so up here I need to say include simpio.h. I've also got these 2 libraries here. This IO stream is what makes cout visible. If you don't include that, you can't print to cout. This console.h is making the program pop up on the screen as its own nice little window. That's one of our libraries to pop up that graphical console. So I recompile and now it works. Now that I included simpio, how old are you? And I say go away. And it says that's an illegal integer. Try again. Young at heart. It doesn't like that. Okay, fine, 38. Oh, I wish I am. I don't wish I were 38, but I am. Okay, so it re-prompts. I guess it doesn't prompt until I'm honest, but at least it prompts until I type an integer, right? So that's an example of using these input-output functions from our Stanford library. So that's a small example of like why we have these libraries. We want to have you guys write programs that are robust, and we don't want the input part to be hard because that's not very interesting. This class isn't about reading input. It's about more interesting things than that. So we don't want this part to be part that takes a lot of code to get right. You know what I mean? How are we doing so far? You have any questions about this? No? Okay. Yeah, question.
Can we access like can we look at how get integer is implemented? Like, do we have access
Oh, okay, that's a good question. How do I know so a couple questions, maybe I'll add to your question. You said, how do I know how get integer works? How is it implemented? I'll follow on to that, like how do I know what all the functions that there are that I can use, right? So in terms of knowing what functions there are, some of them I'll put on the slides. I'll try to say, here's the ones I think you really need to know. So that's kind of your subset. But if you really want a list of everything, if you go to the class webpage, up in the top bar, there's a link that says Stanford C++ Library. It won't let me click it because the internet hates me. It doesn't work. But if you click that somewhere else, it'll show a list of all the different headings and all the different functions that they have. And so that's a nice reference of what they do and what their names are and stuff like that. But to answer your actual question, like how do I know how this works? What if I'm curious? You can select any name of anything and you can right click and you can say follow symbol and it'll jump into the code for that thing. So this is the code for get integer. You can read it. Some of it's a little weird, like what is all this stuff? But I mean, you can at least see and look. Well, what's that? Well, maybe I'll follow that symbol. You know, you can get lost in the matrix here a little bit. But you can look at all the source code of all the libraries. That's kind of cool. In fact, you can even look at like where's C out follow symbol. It took me into some IO stream head. I don't know. I don't understand all that stuff. I'm going to get out of there. But yeah, you can follow symbols to learn where things are and how they're implemented and stuff. Okay. Any other questions so far?
If you follow it into the stream, how do you get back?
If you follow, how do I get back? Well, you know, if you go in Inception, you have to have a kick and it wakes you up and then you're back. No. So one thing is down here in the corner, it'll say like what documents are open so you can click between them. The other thing is just I could close with an X. I could just close this one and then it goes back to the other ones. So yeah. There's a lot of different ways. Also, like over here is a list of all the files in the project, so you can like double click on what file you want to edit and stuff like that. There's a little run button here. You can click to run. There's a lot of nice, cute little features here in this thing, right? Okay, since we're doing good, can I show you something? I wasn't going to show you this till Wednesday, but you guys seem like a savvy bunch. How about this? How do you write a function in this language? We're going to talk a lot about functions next lecture. How do you write a function? Well, what would the function do? I don't know. What if we had something, or why do you want functions in the program in general? Why would I want to do that? What do they get you? What do they accomplish? Yeah, right.
Simplify your main code.
Simplifies your main because instead of a bunch of statements, you make one that jumps somewhere else. Yeah, that's a good reason to use a function. Is there any other reason to use a function? Yes?
You gotta figure out if it's going wrong, like where it's going wrong.
It can kind of help break your program up. You can get a function working, and then you know that part works, this part might not work. Sure, great. Kind of logical separation of your code. Give your code more structure. Anything else? Yeah?
Do you use the same code that simplifies?
If you have the same code in multiple places, you don't want to write the code repeatedly, right? That's great. You know there's only 3 things a computer scientist hates, right? Redundancy, inefficiency, and redundancy. So we don't want to have 2 of those 3 things in our program. So like what if we have, what if we're writing a song and it's like, I don't know. This is this story. I don't want to get the lyrics wrong. All about how my life got flipped, turned upside down. Whatever. You have some kind of like, you're writing a song, but it's repetitive, so you're repeating it over and over. If you had that code at the start of the program, and you also had that same code at the end of the program, and you say, oh golly, I've got twice the same code. So you could write a function called like void song paste, right? So when you're writing a function, you write if it returns any values, which this one does not, you write its name, you write any parameters it needs, which this one doesn't need anything, and then inside braces you write the statements to execute, right? So now here, instead of all this, you just say song, and that's an alias for those 4 lines, right? So that's important. And then at the end of the program, we say song again, right? So now we avoided that redundancy. That's cool. I'll compile it, and I'll run it just to confirm that it works. It prints the silly song lyrics once, how old am I, 38, and it prints the silly song lyrics again. That's pretty cool. We'll end on something shitty about C++. Ready? If you take this function and move it to the bottom of the program, right? So main's first. It doesn't compile. It says song was not declared in this scope. Because C++, it can't find something that's declared underneath where you use it. Because in 1983, they were all dumbasses, apparently. Stay tuned. On Wednesday, I will show you how to work around this dumb problem in C++. Thanks, everyone. I will see you Wednesday. Take care. Go install Qt Creator.